Alright, so today we're talking about linear relations. We have three definitions up here to start with. A relation is a description of how two variables are connected. The independent variable, guys, is the variable whose values you choose, usually placed on the left-hand side of a column, on the left-hand side of a table, and on the horizontal axis of a graph. The dependent variable is the ones you calculate. So you'll choose the independent variable, you'll put it into your equation, and then you'll calculate the dependent variable. This one ends up on the right-hand column in a table, or on the vertical axis of the graph. On the vertical axis of the graph.
Sorry, what's column?
It's supposed to say column.
Oh.
Alright, so the independent variable would go on which axis? The x-axis or the y-axis? Right, x.
I don't know the column.
Neither do I, apparently. Alright, so dependent variable, where would that end up on our graph? The x-axis or y-axis? There's only one option left. Which one's the vertical axis? Y. Thank you very much. Alright, so here we have our table. Let's say I'm running a business where I deliver cars. I choose how many cars they deliver, or the customer chooses how many cars I'm going to deliver. But no matter what, it's going to cost them $25. On this side here, we have our independent variable, because that's the one we're choosing. On this side here, we have our dependent variable, because that's the one we're calculating. Okay. Alright. Alright. Can someone help me calculate these? What would the first one is 25. That one's hard to calculate for us. What would the second one be? What's 20 multiplied by 1 plus 25? 45. Alright. So, just for delivering one car, how much does it cost them? $45. How much does each car cost? Not 25. No. How much does it cost to deliver each car? No, that's the starting fee. $25 is the starting fee. $20. It costs $20 to deliver each car. So what's the second one? 20 times 2 plus 25. So 65. So we delivered two cars. Each costs $20 plus our startup cost of $25. What about the third one? 85. Pretty easy once you get the pattern. Alright, so down here, again, we have our independent variable. And over here, we have our dependent variable. Now, if we were to put a line through this, I'm awful at connect the dots, so forgive me. But we see we have a line. The relationship is linear. Discrete. This is a set of data that cannot be broken up into smaller parts. Can I deliver half of a car? I mean, technically yes, but no if we want it to be, usable. So we can't actually break up this set of data. We can't deliver half of a car. So that's a good definition to copy down as well. So a set of data that cannot be broken into smaller parts. Discrete. Alright, we usually connect discrete lines with the dotted line. because you can't connect the individual points, even though it still makes up a linear relationship. Continuous. Continuous set of data is a set of data that can be broken down into smaller parts and still have meaning. So let's say I really wanted to eat a lot of donuts. Guys, listen up. And every minute or so, I can eat about 2 donuts, which is not true. I can probably eat way more than that. All right. One other thing I wanted to remind you of. If we were to make these in ordered pairs, what would they look like? What would they look like? What does an ordered pair look like? Does anyone remember? Right, an ordered pair looks something like this. So you have the x, comma, y. Those are the numbers. So if we were going to make, let's say, this one here into an ordered pair, it would be 2, 4. So those are ordered pairs. If we were to graph this, it'd look something like this. And this time, because this is a continuous set of data, we can actually put a solid line through the dots. Now, how many donuts have I eaten at about 1.5 minutes? So about here.
2.5.
2. What is this? So it would go to about here. 3 donuts. So at 1.5 minutes, I've eaten 3 donuts. We can break this set of data up into individual parts. It would even make sense if we were go to 2 minutes and 2.25 minutes. I would have eaten, like, say, 4.5 donuts. Donuts are something that can be broken up into individual smaller parts. So it still makes sense to say 2.5 donuts, 2.25 donuts, 2.125 of a donut, but we can break this up into smaller parts. So that's what makes this continuous. This would be another good definition to write down. Interpolate is to estimate a value between 2 known values, which is exactly what we just did in the previous example. So let's say, how many will I have eaten, say, at around 4.5 minutes? How many donuts will I have eaten around that point, do you think? Any guesses? If I can eat 2 donuts every minute, how many do I eat in a half of a minute? 1. So 9 is the answer. We can do this on a graph too. Often you'll be asked to interpolate from graphs. So at 2.5 minutes, how many will I have eaten? 5. That's interpolating. Funny word, I know, but that's what it means. Extrapolate. To estimate a value before or after a set of known values. So here we know we start at 0, and since we're at time, we can't go negative time, can't go back in time. We're not a time lord. But let's say let's say we go to 6 minutes. How many donuts will I have eaten after about 6 minutes?
12.
12 donuts, exactly, because I eat 2 every minute. What about 7?
14.
14, exactly. So that's extrapolating. Going beyond the set of data you have now to estimate how much you will have in the future. Since I'm awful with connect the dots, it's not going to be perfectly accurate. But we can do this with graphs too. So if we go up to 6, it should be at around 12, even though it's not. Because like I said, I'm awful at connect the dots. 7 should be somewhere around 14. But what we're doing when we extrapolate is estimating what the data will be based on the trend line after our set of data. Or before, but usually after. So graphing from a table of values. Who's done this before? I'm assuming most, if not all of you have. So what we do is we just take these points here, make them into ordered pairs. So 0, 0, 1, 4, 2, 8, 3, 12, 4, 16. And you're right. We are multiplying it by something. Exactly. We're multiplying each one by 4. That's the pattern here. So the first point was 0, 0. Second point was 1, 4. 1, 2, 3, 4. Alright. Second point, 2 times 4 is 8. 5, 6, 7, 8. 3 times 4? 12. And 4 times 4, or 4 squared? 16. Alright, again, we have ourselves a linear relationship. I hit all the dots this time. Alright. So, I have to start over because I forgot to hit record. I want to watch all the Fast and the Furious movies, all the Lord of the Rings movies, and all the Harry Potter movies. How long will it take me to watch? So how many movies do we have in Fast and Furious? What is it? 7? Okay. What about Lord of the Rings, including the Hobbit movies?
Is there like 5? I think. I don't know how many those are.
Alright. I think there's 6. Because there's 3 Hobbit movies and 3 Lord of the Rings movies. So we got 6. Alright, how many Harry Potter movies are there?
8.
Alright, so we got 8 Harry Potter movies. That gives us a total of what? How many movies is that total? 7 plus 8 plus 6. 21. Alright. So we got 21 movies in total. Shh, guys, listen up. So how long is it going to take me to watch all of the movies if I watch 3 movies a day? So let's make a table of values and plot it on a graph. On the 0th day, no days have gone by, I've watched no movies. We have 21 movies left. After 1 day, and like I said, I'm going to watch 3 movies a day. What do we get? How many movies are left? 18. 2 days? 15 movies left. 3, 12, 4, 9, 5, 6, 6, 3, and 7, 0, exactly. Alright. Someone get these points down because we're going to graph them. So we just took the data from the question, we took the words, and we turned them into a table of values. On the 0th day, how many movies do I have left? I haven't watched any movies at all. 21 left. After 1 day, how many movies do I have left? 18, 20, 19, 18. Alright. 2 days, 15. 3 days, 10, 11, 12. So it's just as easy as this. 4 days, 9. That's a really big dot. I can't control it, I swear. 5 days, 6. That's a really small dot. 6, 3, 1, 2, 3. And after 7 days of watching movies, 0. So we can see that this is also straight line. Oh, almost so close. Alright, so it took me 7 days to watch all those movies. Not that you can see that because the dot's covering it up. But we still have a linear relationship. We can figure out a lot of things from this. I don't know where I was going with that.